Thank you. So my name is Paul Watts, and I am grateful to be here, and I'm grateful to be given the most coveted time slot, the just before lunch time slot, to talk about everybody's favorite subject, software testing. All right. Are we working here? There we go. All right, who am I? I've been writing Python for a lot longer than I care to admit. And I've been a developer for a lot longer than I care to admit. And in every single team that I've been on, I've always been the person who's been the most passionate about testing, writing unit tests, being that annoying person to actually make sure that people are writing unit tests. So it's a subject that's I'm really passionate about. It's close to my heart. And I don't always take selfies, but when I do, they're next to space planes. So the first thing we're going to be talking about is reducing boilerplate using PyTest fixtures. So show of hands, how many of you heard of PyTest? Wow, look at that. How many use PyTest? Cool, that's awesome. So if you've not heard of it or if you're not using it, what PyTest is a test runner. So what it'll do is find all of your tests and run them. But it's also something more. It's also a framework for creating better tests. So it has a bunch of really cool things that comes with it that make tests a lot easier and a lot more fun to write. And the coolest thing in PyTest, in my opinion, are PyTest fixtures. And PyTest fixtures are pretty simple. They're just simple functions that help you reuse test setup logic. And so here's an example of a fixture. This is straight out of PyTest documentation. And so a fixture is just a decorated function. So you can see this top function has this decorator pytest.fixture. And what it does is it runs some amount of setup code and returns a fixture object, in this case, this SMTP object. And to use a fixture in your test function, you just pass the name of the fixture function, so SMTP connection, as a parameter to your test. And when that happens, PyTest will call the fixture function and pass the fixture object, this SMTP object, as a parameter to the test. And it's simple and it's really powerful, and it makes things life a lot cooler. So if you're like me, you write a lot of APIs, and if you're like me, you write a lot of API tests. So what I'm going to give you now is sort of a real-world example about how to take an API test and convert it to using PyTest fixtures. So this is a simple example, and this is Django. If you're not familiar with Django, that's fine. You could possibly use this in another web framework like Flask. But what we have here is we have a widget resource, and we just want to test that you can get one of these widgets. And even in this simple example, you have all of the setup code. So the first 3 lines, you have to create this widget object. If your API is authenticated, you have to create a user, and you have to authenticate the user. And then you actually can do the thing that you're wanting to do, which is actually just get the widget resource, and then assert that what you've gotten is what you actually want. So and one thing I want to mention is that this setup code that you write down is you have to do that for every single test. And sure, you can put it in like a setup or teardown method, but a lot of times that actually becomes tricky to use across test cases. If you have a lot of test classes, you might need to you have to have a base class. So there's a lot of more stuff that you can do, and it gets a lot complicated when you try to share setup code across tests. I want to take a little bit of a digression and talk to you about the AAA pattern, which is arrange, act, assert. And this is actually something that this test follows. It's a great pattern to follow with tests, which is tests should be formatted in 3 specific blocks, which are, one, you arrange the objects on which your test depends. Two, you act on those objects. And three, you assert that your actions cause the desired effect. So it's a great pattern. It makes tests a lot easier to read and a lot easier to write. So let's convert this to PyTest. So first, let's create our fixtures. And so this is arranging our test objects. So what we have is we have a fixture that creates our API client. We have a fixture that creates a Django user. And this third one, this auth client, shows you how you can actually use compose PyTest fixtures. So this auth client one, the third one, depends on the previous two. So what it does is it will get called with the API client and the Django user, and then authenticate that client, and then return the client. And if I can scroll down here, maybe I can't scroll down. There's also a widget fixture that just creates a widget. So here's what our converted test looks like. So as you can see, all of the actual setup code got removed and is now in the PyTest fixtures. So all we have all of our arrangement code is in the test parameters. And the test is just exactly what we're operating on, what we're acting on, and then what we're asserting. So PyTest fixtures allow us to reuse all that setup code. And notice that you actually don't even have to worry about that we created a user in the background and authenticated it. All it basically says is we need an authenticated client. And this actually follows another really good maxim of writing tests, which is a good test should only change if the behavior changes, not if the setup code changes. We can change the way auth client is set up and is modified, and we don't have to change this test at all. So over the past year, I spent a good part of time, not the entire year, but some time, changing all my projects from unit tests, class-based tests, to PyTest fixtures. So here's a little bit of lessons that I came up with doing that. And the first lesson is, not every all setup can be fixtures. Some tests have some really complex tests set up, and sometimes that will actually still need to be in the body, and that's fine. It's if you don't need to reuse the test setup, that's great. You may not get fewer total lines of code. This is actually something surprising, and it might actually contradict what I was saying earlier. But what I found was when I started converting tests from my class-based tests to fixture-based tests, I noticed that I could get a lot more focused in my tests. So a lot of tests that I had, because I was lazy and didn't want to recopy or try to reuse a lot of test code, I would do too much in a particular test. I would try to test too many things. And being able to split up setup code into these reusable small components makes it easier to write smaller and more focused tests. You end up actually having less code in each individual test, even if you might actually have, and you might have more tests and more code in that. I think, think of it kind of like the Simpsons paradox of testing. If anybody laughed at that, they're a stats nerd. Don't Wikipedia it until you're done, until I'm done. Okay, so another thing, mocks. So mocks are like pieces of test code that you write that replace parts of the system under test. So you can test like external requests, like HTTP calls, things like that, external libraries. And mocks or fixtures are a great way of actually setting up mocks, because fixtures not only have a way of setting up setting up code, but there's also a way of adding teardown code to fixtures. And I don't really have time to go on this here, but pytest mark parameterize is awesome. It's a way of actually being able to write multiple tests where certain inputs and outputs can change, and you can actually write many different tests and reuse different test code. Really simply. Encourage everybody to check that out. Okay, now let's talk about property-based testing. So in this previous test, we only had one example of this name. So this last line, we were just asserting that we had some name that we defined in our fixture, and we're just asserting that when we got it, that was the name that were passed in. But this is only one example, and what we really want to do is we want to be able to test against a number of examples. So like here, we want to test against the empty string, or maybe we want to test against uncommon inputs. And that's what property-based testing does for you. So, and if you're using property-based testing in Python, the go-to library is called Hypothesis. Now, how many of you heard of Hypothesis? Cool, a lot. How many people use Hypothesis? All right, well, we're all gonna learn something a little bit here. So, Hypothesis is a really super powerful library, but it does require a little bit of a change in how you think about writing tests. And so instead of actually thinking about writing just simple examples like before, what you do in property-based testing is you write tests that make statements about how the code should work. So you decide what guarantees your code should make. And then you express those guarantees, you express those statements as tests. And then Hypothesis will generate the possible test cases for you. That's a lot to take in, so I'm going to give you a real-world example. A lot of introductions to Hypothesis start out by testing simple functions like addition, and that's really great with kind of picking up the kind of the gist of how it works. But I know y'all are smart, and we can jump past that. But also, the other thing is when I first started going down the Hypothesis route, I found that those simple tests, it was a big jump between those simple tests, like addition, into how to actually use this in a real-world test. And so this example is a little bit more complex, but hopefully it's a good way of actually approaching how to test real code. So what we have is actually this batcher function. So this batcher function takes a sequence, so a list or a tuple. It takes a batch size, and what it does is it continually returns a batch of that sequence. So if you pass it a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a batch size of 3, the first call will return 1, 2, 3, the second call 4, 5, 6, third 7, 8, 9, 10. All right, simple. And when you're doing an example-based test, that's actually one way of saying, okay, well, why don't I just test 1 through 10? When you're approaching it with a property-based mindset, what you want to ask is the question, given the function's input, what can we say about its output? What guarantees do we want to check in this? What kind of guarantees does this function have that we want to check? So one thing we might ask is, given a list, it returns the same number of items in that list. It's a guarantee, something that we can probably say, like, yeah, this code should probably do that. And here's how you would write that in Hypothesis. So Hypothesis is run by two big things. It's this decorator called given, and these things called strategies. And strategies are these ways of just generating a bunch of different examples based on a class of input. So what this is saying, this decorator is saying, given lists of integers, I'm saying all of the examples that you want, the space of examples to take from are lists of integers, and pass a list of integer to this function. We call our batcher function, sum all the lengths of each batch, and then just assert that the total sum here is the length of the list that we got. And what happens here is hypothesis will then call this function repeatedly. I think by default it does it like 100 times with all of these different examples. So what we have is just by describing the inputs of our test, hypothesis created 100 different tests. Here's another example of what we might be, another guarantee that we might want to check, which is given a list, it returns the item as in that list. This is actually a good pattern to use when thinking about property-based testing for any function that has a natural inverse. So like if you're maybe writing an encoder, decoder, something like that. I think some people call it there and back again. So what you can do is you can actually pass in some input, perform the operation, invert it, and make sure you get back what you passed in. And that's what this does. This is, so again, we have this given, and given list of integers, again, the property space we have are just lists of integers, call our function, and you don't have to necessarily worry about what this means. Chain from iter this basically will flatten a list of iterables. And what happens is we just assert that when we flatten what we get back, we actually just have what we passed in. All right. Cool. And this is a great way of thinking about property-based tests. You know, think about, given certain inputs, what should hold true as a logical consequence of those inputs? And if you want to sound nerdy, you can use the term propositional calculus. You're creating statements, yes, it is nerdy. You're creating statements that logically hold true given certain axioms. And as it turns out, actually thinking about testing this way actually is also a great way to think about your example-based tests. All right, going back to our API test again. So I know everybody here is really diligent about testing, writing tests, making great tests. And so immediately when you saw this, you said, hey, Paul, you forgot a doc string. You know, okay, you caught me. I didn't have a doc string. I forgot to add one. And so actually what I could do, you know, one way of actually approaching this is like the previous examples that I did, which is start with the doc string. Describe what your actually test is trying to do. So the doc string describes the test, and if in this case we're testing a get method, and we want to say, given a widget and an authorized user, you can get it from the API. And when you do this, it actually entirely starts creating, you actually immediately get what your inputs to the test are. So based on this, we can say, okay, well, we need an auth client, we need a widget, and then we can actually write the test. And notice here, these are PyTest fixtures, but if I wanted to convert this test to a hypothesis test, so if I wanted to convert this test to a hypothesis test, all I need to do is add this given decorator. So I create this strategy that generates widgets, And then all I pass this decorator, boom, I have a hypothesis test. So when we thought about how once we thought about expressing our function as its terms of its inputs and outputs, we can actually create more focused, more self-describing, and more fluent tests. All right, so questions. What if I don't use PyTest? You can still use hypothesis without PyTest. It's possible. If you use something like unit test, I think you can use it with no's. I'm not sure. One thing I should mention is if you use unit test or if you use Django, PyTest is a drop-in replacement for the Django test runner. It took me like 30 minutes to actually replace it, and everything worked. And then you can actually convert your unit test classes slowly, over time. You don't have to do it all in one go. Do I have to convert all of my tests to property-based tests? No, I don't think. I mean, there's some tests that don't necessarily fit with the model. In addition, example-based testing can actually be just as useful for readability. You can have an example-based test right alongside a property-based test. And to be honest, writing property-based tests takes time. You have to kind of think about some of these things. You have to actually not only writing the tests take time, but running the test takes time. And you have to weigh the costs about how much those tests are worth to run and to create. And sometimes you might decide they're not. I mean, in my experience, the best cases for property-based testing are pure functions. So truly like unit tests and higher level integration tests, like the API example, might not be the best for property-based tests, but you can still do them. Quickly, some next steps. Hypothesis is a really powerful library that has a lot of different strategies. You can actually generate NumPy arrays. You can generate pandas data frames. And if you use something like Factory Boy or something like that to generate mock objects, you can actually use hypothesis to do that as well. It's pretty easy to set up using this build strategy that allows you to build arbitrary objects. Some other resources. There's a great PyCon talk about that goes into more depth in hypothesis and goes into talking about contract-based development, which is kind of really cool. If you have any trouble with coming up with properties, this is a non-Python specific, but it shows you some different strategies for coming up with properties, testing, and all right. And one caveat if you're trying to mix PyTest at fixtures and a hypothesis, it's possible. You just kind of have to know a little bit about what you're doing. Thank you to Marietta and Don Marietta helped me with my CFP, Marietta and Don and all of the organizers for this conference. Dustin helped me improve this, so I hope you enjoyed it. Russell is the person who kind of got me onto the hypothesis train, and I don't know if I can call you out, but he's literally writing the book on it. Chris inspired me to convert my Django project to PyTest, and Alan and Mael inspired me to submit this talk, and they're just all around great people. And thank you again to all the PyCascades volunteers, and thank you to all of you. And let's go get lunch.